Okay. All right. We are good. So we want to go ahead and have prayer. I'll go ahead and say it. Okay. Our dear Father in heaven, we are so grateful for this opportunity to be together as a class members and to study the subject that we are able to do. And we're grateful for the opportunity that we have to learn from each other and to help each other through this course. Please help us as we study today, that we will be able to help each other and understand the lesson, and that our minds will be able to retain the information that we are learning, and that we will be able to retain the information. And please bless Mitch, that he will be able to join us, and bless our families as we are away from them studying, but they will be blessed as well. And these things we ask for in the name of Jesus Christ. Amen.
Amen. Thank you.
Thank you.
All right. Okay. So,
we're on lesson 10, yeah?
yeah, lesson 10.
Okay. So, we want to do the part 2 really quick?
Yeah, so pulling up my homework.
Good.
Yeah, I definitely struggled with this chapter, though.
It's a hard one. I have a hard time understanding this stuff. Okay.
Using it first.
Okay.
I can do number 6.
Okay.
What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? That was that you had to, a simple random sample was drawn from the population. The sigma is assumed to be known, and then that is normally distributed.
Yep.
Yep.
Cool.
All right, I'll do number 7. What is, the graduate management admissions test is used as an admission criteria in many Masters of Business Administration programs. UIUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for these 50 students is 541. Assuming a population standard deviation, sigma, oh no, that's not sigma, that's something else, of 32, answer the following questions. What is the point estimate for the population mean? And I got, oh, it's 541.
Okay. So create a 95% confidence interval for the population mean. So, sorry, I am behind on this part, so let me just a second, and I will have it. times I is, and that is 8.860, 8.870. Is that right? Is that what you guys got?
No.
No. I told you this is the worst chapter for me. Okay.
So the confidence level, well, the margin of error is 8.870.
Okay.
But what they're asking for is the interval.
So is that the
Just add that
1.960
and
is the confidence interval is
what was
1.90 is the confidence interval?
the confidence interval would be, you add the 8.87 to
Oh, to
the
the
mean.
541
and
subtract it?
yeah, you add it and subtract it.
Okay, so then that would be, just 1 second, and I got it. 541 plus 8.870. Or 549.87, or 532.13.
Right.
So, sorry, 1 second. I put all the formulas in, but I put everything in the wrong place. You said 549.87 and 532.13?
Yeah.
Okay, cool.
Yes.
Oh, sorry, 1 second. Let me fix my Excel sheet quick. Okay, say the sample size changes to 100, compute a 95% confidence interval with the same point estimate. So that would be 547.27 and 534.73.
Yep.
What was the other one? 547.27 and what?
534.73.
Just make sure to take those to 3 decimal places on the tests.
Oh, is it 3?
Yeah.
Okay.
All right, number 10. How does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval for a sample size of 100? Well, the sample size of 100, the margin of error.
Oh, yeah. That's right. remember in the lesson that it said that when the sample size increases, the margin of error goes down. But if something else increases, do you remember what the other thing that increases? And then the sample, or then
Confidence,
sorry.
confidence interval.
Oh, okay. Well, I mean, there was something else that corresponded with the confidence interval. That if that went up, then the confidence interval would go up as well. I can't remember.
Oh, if the sample size changes, if you get a bigger sample, you decrease the interval. If you change the confidence interval, you change the margin of error also. If you decrease the confidence level, you'll decrease the margin of error. If you increase the confidence interval, like if you go from 90 to 95, you'll get a larger spread.
Okay. Cool. Is it my turn?
I think mine.
Okay.
So create a 90% confidence interval for the original 50 students. So we're gonna do, so it's gonna be 533.556 and 548.444.
I got different answers on that one.
Okay.
I got 548.444 and 533.556. That's not what you got, Pete.
Hang on. It is when I use the 3-digit confidence intervals instead of the 2-digit.
Yeah, because it would be 1.645 for the 90%, right?
Yeah.
Yep.
Yeah. So then you do the 32 divided by square root of 50, right?
Yeah, no, I got that.
The 533.556.
Yes.
Okay.
And
And
548.444.
548.444.
Yeah.
Okay.
Yeah.
Awesome. How does the margin of error for a 95% confidence interval that you compute in question 8 compare to the margin of error or a 90% confidence interval that you compare in question 11? So this is what we were talking about, where if you have the margin of error increase, then the confidence interval will increase as well.
Yes.
Okay, so yeah, so it's the same. As it gets smaller from 95 to 90, then it'll be, the confidence interval will be smaller.
All right, 13. BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure that he has a level of accuracy for a 95% confidence interval? So let me change that. Delete that. Okay. All right. Anybody have any problems with that one?
What did you get?
158.
Okay, so I got 157. Do you round up automatically, or is it
Yes, you always round up.
always round up? Okay, let me put that in my formula.
Pete, remind me again, you were telling me when we were waiting for Sean, what was the formula you switched to for that? Because that on the quiz, that's the one that I had a hard time with.
Okay, that's your Z times the standard deviation, the margin of error, and that whole quantity squared.
And the whole quantity. Okay. So you square the Z times the standard deviation. Okay.
Okay, now I got it figured out. That's good.
And then you always round up. Okay.
Yes.
Okay. Okay.
Cool. Feel good about that?
Yeah.
Great.
Okay. So now we'll go here. Okay. All right. Sounds good. Move on to the quiz.
Yeah, there's only 14 questions. That's nice.
Okay, so I'll start with 3.
Okay.
Number
All
3.
right. So find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample size is 25, round up 3 decimal places. So 16.450.
Yep.
16. How did you get that?
You do the, so we're going to use the formula where you go, go 50 divided by the square root of 25, and then you're going to multiply that by 1.645.
Oh. And you got 16.450.
450.
Okay. I accidentally put the wrong Z score. Okay. I can do question 4. Which of the following statements is true? Standard deviation squared is an interval estimator of, okay, I think it's the second one.
Yes.
Yeah.
I was gonna say, I know it's not the first because that's the one I guessed and got it wrong.
Yeah,
Hey, Mitch,
this
how are you?
X bar is the
Hey
sample
guys,
mean.
sorry about that. I'm a little late.
Yeah, morning.
Morning.
Yeah, morning.
Okay, we're in the quiz right now, Mitch. Trying to open that up.
Okay. Yeah, I'm just about there. We're on the group 10 quiz.
Yeah.
Yeah.
Mhm.
Sean, Pete, did you confirm it is number 2? The second one?
Yes, it is.
Okay.
It is. The sample mean is a point estimator of the population mean.
Yeah.
All right. So Mitch, we've only done number 3 and 4 so far on the quiz.
Okay. What did you guys get for 3 and 4?
Number 3, 16.450.
Okay.
And number 4, it's the second one.
Okay. All right. Thank you.
Yep.
All right. So did you guys just barely finish number 4 then?
Yep.
Mhm.
Okay. Will someone already do a number 5?
You can take it.
Okay. I'll take it. So Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation equals 113. She collects the simple random sample of size n equals 64 and computes x equals 526. Use this information for the next 6 questions. What is the point estimate for the true GMAT score? Oh boy, this one I might need a little bit of help on. Is anyone already able to get this one?
You don't need to do any calculations.
Is it already one of the numbers in the problem?
Yep.
The true GMAT score. Okay, I was thinking there was gonna be some complicated problem with it. Maybe the 526.
Yes.
Yep.
Right.
Yes, the point estimate is just a number that they're taking to kind of start everything from. So,
Okay, that's all that is.
yeah.
All right, guess I was just overthinking it.
No, you're good.
Six. What is the margin of error for the 95% confidence interval for the true GMAT score? And I got 27.685.
Yep. That's what I got. Okay. Number 7. What is the lower limit of this confidence interval? I got 498.315.
That's what I got.
315.
0.315, yeah.
The upper limit.
Mitch, do you understand how we got those? The lower and upper limit?
Not really.
So, so that point estimate that you had, the 526, and then Pete found the margin of error of 27.685. So the lower limit, we would subtract the 27.685 from the point estimate.
Oh.
And then the upper limit, we're going to add that margin of error to that to get that upper limit.
Okay.
So question 8, the upper limit of the confidence intervals is 553.685.
Yep.
Yep.
Okay. All right. So question number 9 says, what would happen to the width of the confidence interval if Gina increased the sample size? Wouldn't it increase also?
No.
No. Oh. Maybe is it the opposite?
Yeah. That's going to decrease.
Okay.
Okay. So what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? It's going to increase.
Yep. A bright bulb light bulb company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval and a margin of error of 50 hours. What sample sizes do they need? So that would be 246.
Right.
Okay. Is it my turn?
Yeah.
All right. The mean salaries of actuaries is $100,000, and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level significance of 0.05, and you collect a simple random sample of n equals 36 women's salaries and find that x equals 111,000, and use this information for the next 3 questions. What's the lower limit of this 95% confidence interval? And I'll be honest, I have no idea how to figure that out.
Okay, so first we have to figure out the confidence. We have to figure out the margin of error, right? So
Okay.
you need that formula of the that we use. That is the, we're going to take retake the standard deviation and divide it by the square root of the sample size.
Okay.
and then you're going to multiply it by, we want a 95% confidence interval, and so that's going to be 1.960. So you have your standard deviation of 36,730, and divide that by the square root of your sample size of 36.
Okay, that equals 6,141.67.
And then you're going to multiply that by 1.960.
1.960.
Uh-huh.
Okay. Yeah, 11,998.46.
7.
Or,
Okay.
oh yeah, 0.467.
Yep. Okay, so now your question is to find the lower limit. So you're going to subtract that from the X bar of 11,000. And we want to make it a whole number. So
So around 11,998 up.
yeah.
Okay,
Well,
so that
just subtract your 11,998.467. Subtract that from the 111,000.
okay.
And then we'll round it up. Or round it.
Okay, so it'd be 99,002.
Yep.
Okay.
Perfect.
All right, thank you.
You're welcome. So then when, for the next one, which,
Okay, so I have that
who is
one.
the next one? Pete?
Yep. So what is the upper limit of this 95% confidence interval? Round to the nearest whole number, 22,998.
That's what I got.
Yep.
Hmm.
So he
Well,
just added the number that you found of the 11,998.467. He added that to the 111,000.
Okay, what did that give again?
122,000.
Okay. All right, I see.
Lori, are you up?
I am, and this one I actually got wrong, so I might need help. The 3 requirements that need to be checked when computing the confidence interval for a mean, they are, because I wasn't sure, I knew it needed to have a random sample drawn from the population, but does it have to be a simple random sample?
That's basically what a random sample is.
Oh,
Simple
okay.
random sample.
Okay, good deal. And I knew that we need to know the standard deviation. Oh, so it would be all of the above because it needs to be normally distributed.
Mm-hmm.
So it is all of the above. Okay,
Yeah.
there we go. All right.
Cool.
Perfect.
100.
Sweet. Thanks, guys.
Yeah. Lori and Mitchell, have you guys worked at all at putting the just putting the formulas into Excel and then being able to just put the numbers in and it sets it all up for you?
No, I have not.
It helps so much, like, because
It does.
I have it set up to where I just put in the sample mean, the z-score, the standard deviation, the sample size n, and then it automatically tells me the positive and the negative margins of error. And like,
Okay.
other than instead of just handwriting it every single time, if you just put it all into Excel, it makes it a lot easier. I'm sure
Okay.
Pete can testify to that.
I
All right.
do. I also put my formulas in there. This way, when I'm looking at it, I kind of remember how to do it by hand. Let me see if I can share this. I've got this on my phone, so it may, yeah, get my finger out of the way. So I write the formulas down first when I set up the sheet up here. Can you guys see that?
Uh-huh.
So that's your lower limit, and that's your upper limit. And then I always set up boxes here, and I'll color them like a light yellow. That one I did do a validation on where I could just do the drop-down menu.
Oh,
But then I started realizing, so I colored a little bit different, but then I realized that I was forgetting what the percentile scores were off the top of my head, which I might want to remember for the quizzes and stuff. So I left that. That's why that one's colored a little different. I've got my standard deviation there, or the sample mean there, the z-score. I just used an italics O for the standard deviation, the number, and then the margin of error. Sometimes I'll fill in for this formula here. This formula, I basically took this formula here for the lower limit. I should probably left justify those. And so I take C5, which is this box, and I'll subtract it. And I start using a lot of parentheses to keep the formula in the order that it's in. If you want, you can kind of reverse it so you're not using as many parentheses. But this way it just figures it out for me. The upper limit, I basically just copied that and changed the minus here to a plus.
Mm-hmm.
And then for quiet, for the margin of error, that's basically just your z-score. It's your upper and lower limit without adding it to the sample mean. So I just take the z-score times the quantity of that and the square root of your number. So it shows me what my margin of error is. If I don't know what n is, and I just want to put in a margin of error, because I know what that is. In this case, it's 1199, and if we go up, it'll be 999, and I get rid of my n. Then I've got this formula up here, which is this. In order to find n, it's your z-score times the standard deviation divided by m, and that whole quantity squared. And in my formula, I do the round, I just did round up and then did that formula, so that all I have to do is come over here and plug in whatever numbers I want. Then I look up the answers.
Oh, wow.
yeah. It helps a lot
All right.
if you can figure it out.
Okay, I need to start messing with that.
Excel is an awesome tool. Whenever you take
Yes, it is.
B215, I think is what it is, the business spreadsheet analysis,
Mhm.
you'll learn a lot about Excel, and it helps a ton. But this is a perfect time to learn as well. So
Okay. All right. I'm gonna have to mess with it this weekend.
it'll be fun. And then, like, if you look up anything online, like, there's always somebody's already looked up the same thing, and so you'll be able to figure out how to do everything on Excel.
Okay. I'm gonna look that up. That'll be good. Thank you.
Yeah.
No problem. Did that all make sense?
Yeah, it was good.
Okay.
Perfect.
Good to meet next week then.
Yeah, next Wednesday.
Wednesday, yeah.
Wednesday.
Sounds good. You
All
guys
right.
have a good weekend.
All right.
All right.
You guys
Thanks.
have a good
You
weekend.
guys too.
All right, thank you.
All
Talk to you later.
All right. Thanks,
All
guys.
right. Bye.